In this video, I want to have a look at general solutions to trig equations that involve our tan ratio. So to start with, we're going to consider the equation tan theta equals 1. So we're going to start off the same way as we did with our sine and cos ones. We're going to draw our all stations to central diagram. Now tan is going to be positive in the first and the third quadrants, and our related angle when tan theta equals 1 is 45 degrees or pi on. So we're going to consider each of these solutions separately. So if we have a look at this one here first, we're going to end up with theta equals, on our first revolution, it will just be pi on 4. Then if we come all the way around, we'd have 2 pi plus pi on 4. If we do another revolution, we'd have 4 pi plus pi on 4. And we could keep going. If we go clockwise instead, we'd have all the way around would be minus 2 pi, but then we've got a plus pi on 4 to come back. So minus 2 pi plus pi on 4. If we went around another revolution, we'd have minus 4 pi plus pi on 4. And that could keep going as well. So if we generalize that solution, we could write it as theta equals n pi plus pi on 4, where n is always either 0 or an even number. If we have a look instead at this ray coming down this direction, we would have theta equals, if we go in the anti-clockwise direction first, we'd have pi plus pi on 4. If we do another revolution, we'd have 3 pi plus pi on 4. Another revolution would give us 5 pi plus pi on 4. And we could keep going. If we go the other direction, we'd end up with minus pi plus pi on 4. Or we could end up with minus 3 pi plus pi on 4 if we do another revolution, and that'll keep going as well. So if we generalize this one, it's always still got that plus pi on 4, but this time our numbers in front of our pi are always odd. So we could write it as n pi plus pi on 4, where n is odd. Now we want to write one general solution that combines both of these, but if you have a look at them, they're both exactly the same because both times we were always adding that pi on 4. So regardless of whether n is 0, even, or odd, our solution, our general solution, is just going to be n pi plus pi on 4. If we have a look at what that looks like graphically, here we've got our graph of tan theta, and I'm also going to put in there the line y equals 1. So our points of intersection are our solutions. So if we've got n pi plus pi on 4, if n was 0, we'd just have pi on 4 as our solution. If n was 1, we'd have pi plus pi on 4. Then we've got 2 pi plus pi on 4, 3 pi plus pi on 4 would be here. And it goes in the negatives as well. So we'd have minus pi plus pi on 4, minus 2 pi plus pi on 4, and so on. So you can see how it works graphically as well. So the general solution for any trig equation involving tan would be that theta equals n pi plus alpha, where alpha is that first positive solution. That's in radians. If we wanted to write it in degrees, we'd write it as 180 degrees times n plus alpha. So let's have a look at an example. So as asked us to find the general solution to tan theta equals 3 cot theta. So the first thing I'm going to do is, I'm not really liking this cot here, so I'm going to manipulate that so that we have tan theta equals 3, and we know that cot is the same as 1 on tan. So we could write that as 3 over tan theta. Now if we rearrange that, we could multiply both sides of that equation by tan, and we'd end up with tan squared theta equals 3. Now to solve that, I could take the square root of both sides, and I'd end up with tan theta equals plus or minus the square root of 3. Now to go through and solve this, I'm going to split this into two equations, so into its two cases. So I'm going to write it up here. We've either got tan theta equals the positive square root of 3, or tan theta equals negative root 3. So we can come up with a general solution for each of those things. So for this one, if we draw our all stations to central diagram, tan is positive in the first and the third, and our related angle is pi on 3. So that's going to be our alpha in here. So we'd end up with theta equals n pi plus pi on 3. For this one, if we draw our all stations to central diagram, tan is negative in the second and the fourth quadrants, and our related angle is still pi on 3. But that means that our first positive solution is this angle here, which actually comes out to be, if that's 3 pi on 3, that'd be 2 pi on 3. So that's going to be our alpha there. So we'd end up with theta equals n pi plus 2 pi on 3. So those two general solutions are solutions to this equation.